Welcome to qnawire.
Okay, so let's just start by listing out the things that we know. So we know that the max energy is 8 joules. Whoop, 8 joules. And then we know that it happens in 10 milliseconds. So that's 10 times 10 to the minus 3 seconds. And then we know that the mass is 5 kilograms. So 5 kilograms. Right. So that's what we have to work with. So we want to know the maximum, the maximum velocity of the car um, that could have sustained this crash without breaking the neck bones. And basically, we want to do that by looking at the kinetic energy of the car. We know that the kinetic energy can't go above that 8 joules, right? Because we're going to convert all of that into absorbing into the neck bones. So basically, we say the kinetic energy is same as always, 1/2 mv squared. Half mv squared. And then when we solve for v, we get v is equal to 2e over m. Great. And I guess I should make that look like an m. There we go. All right, so v equals 2e over m. And this is where we remember that e, that's this energy here, this 8 joules. So now we just have to solve that for v. So that's 2 times 8 over mass, which is 5, and then the square root of that. And I trust you to do your own arithmetic on this. And so that comes out to be 4 over root 5 meters per second. And if you want to put that in miles per hour, you just multiply by 2.23. So that is 2.23 times 4 over root 5 miles per hour. Good. And to be really frank, the 2.23, I just got that by Googling. You could do it by dimensional analysis, but I think if you're in this course, you can probably figure that out on your own. It's much faster to just Google that. Right. Now we want to know the acceleration of the passengers. So let's get a new whiteboard up. Let's see. New whiteboard. There we go. All right. So get a new whiteboard up. Right. So now we basically just say acceleration is equal to the change in velocity over change in time, right? Same equation we've always used for acceleration, right? And then we plug in our velocity that we just calculated in meters per second. That's important. And then divide that by the time, which was 10 times 10 to the minus 3 seconds. And then that should come out to 4 over root 5 times 10 squared meters per second squared. Cool. And then if you want to turn it into G, what you can do to do that is you can realize that G is about 10, and we have two 10s here. We have 10 squared, so we can just turn one of those into G. And then basically, if you want to think about it that way, you have the other 10 that can get absorbed into the 4 and make it 40, and then you just have it G. So we can say this is basically 40 over root 5 g. Cool. Now we want to know the force on the necks of the passengers. So that's just F equals ma. So F equals, so F equals ma, where the m is 5 kilograms, and then the acceleration was 4 over root 5 times 10 squared meters per second. If you multiply that out, you get 4 root 5 newtons. So that's 4 root 5 newtons. And I trust you can do the algebra with the units there.